So welcome to Starry Skies, our monthly astronomy magazine. I'm Mark Hardaker.
And I'm Steve Tonkin.
And we wish you all a very happy New Year 2004.
Indeed. Let's hope it's a little bit clearer than 2023.
Wasn't it rotten? What a rotten year, Steve.
Oh, as for stargazing, there were some very good nights, but there were very few and far between.
Yeah, they were. Compared to previous years, and I've been living here in the south for 5 or 6 years now, and this is the worst possible year. It was really, really poor. Climate change possibly causing it, I don't know, but definitely we seem to have more storms and more rain and clouds than ever before, right?
Indeed, yeah. Well, I think it's fairly clear we do have more cloud as there's more water in the atmosphere.
Anyway, so today is the 3rd of January, if you're not listening to the repeat. If you're listening to the repeat, of course, that will be Sunday the 7th of January, but today is the 3rd of January. And would you believe that today the Earth is closest to the Sun?
Indeed it is. It is not, as a lot of people think, that the Earth is furthest from the Sun in winter, because, of course, that wouldn't make any sense in the southern hemisphere, would it?
No, absolutely not. And we are the furthest away today at 7:30.
We're the closest today.
Sorry. Yes. Thank you. Correction. We are the closest to the Sun today at 7:38 p.m. So if you're listening to this on the 3rd of January, in about an hour's time, we will be 147,099,586 kilometres from the Sun. I just thought you'd like to know that.
Who's going to count them?
And the opposite, when we are the furthest away from the Sun, which is called
Aphelion.
Aphelion, is on the 5th of July. So that's in the middle of summer, and we'll then be 152 million miles from the Sun. So, yeah, that does prove that we orbit the Sun in an ellipse. So we get nearer and further as the year progresses. Anyway, what else about the 3rd of January, Steve?
One of my favourite meteor showers. It's a little one, it's short and sharp, and it comes from the same parent body as my really favourite one, which was the Geminids, which we talked about last month.
Yeah, we did.
And this is the Quadrantids.
Right.
Why is it called the Quadrantids, Mark?
Well, the source of these meteors, okay, we know it comes from an asteroid, although the bits and pieces that fall through the Earth's atmosphere come from an asteroid. But when we see them approaching us, when we look out into the sky, they appear to come from a spot just at the end of the handle of the plough. But that used to be a constellation years ago, and it was called Quadrans Muralis. What was that?
That's the mural quadrant. So it was a sighting device in the form of a quarter of a circle that was placed onto a wall, hence mural.
Right.
And what they would do is they would sight stars, as this will always be pointing exactly due south, and they would sight stars as they were passing due south, and in that way, by getting their altitude, they could start plotting positions very, very accurately.
Right, and that was called a quadrant, wasn't it? A quadrant. But that constellation, Quadrans Muralis, which was, I think, something in the 1700s when it was identified, it doesn't exist as a constellation anymore. And the only remaining tie to it is this meteor shower, the Quadrantids. So it's, as you were saying, Steve, it's a very sharp, short shower, if I can say that with all the S's, that actually peaks around 10 a.m. on tomorrow, on the 4th of January. So the best time to see it is as late as you can tonight. So around midnight or 1 o'clock if you can stay out so late. Look out for fast meteors. Moon doesn't rise until around midnight, and it's only a quarter moon, so you should be able to see them. Look towards the plough, look just below the plough, and that's where they will appear to come from. But they will flash across the sky, really, wherever you're looking.
Yeah, if you look exactly where they come from, they'll be coming straight at you, so they'll be very, very short trails indeed.
Yeah, a bit like looking at a rainstorm, looking straight up. You see the raindrops coming straight into your eye, but all the others are streaking to the... Anyway.
Yeah, right.
Whatever.
Moving on.
So moving right out, what else is to see in the evening sky for the rest of this first month of 2024?
Well, there's my favourite bright planet, which is Jupiter.
Absolutely.
It's really interesting. Very easy to see. Once it starts getting dark, you'll see it almost due south, nice and high up. and have a look with binoculars. I know we say this every month, and you can see some of the moons that Galileo saw.
Yeah. And every night they're in a different position. So, in fact, at the beginning of the evening, as it drops dark, you have a look at the moons, and then look just before bedtime, 3 or 4 hours later, perhaps, and you'll see that the moons have changed position. They orbit the planet very, very quickly, and you can see the changes certainly within an hour or two.
Yeah.
And from night to night, they're completely different.
Yeah.
Completely different.
If you've got a telescope, have a look at it, and you will also see the equatorial bands, these dark bands that go across it. And if you're lucky, you will also see what's called the Great Red Spot, which isn't as great as it once was, but it's a storm that's been raging for 300 years at least.
Yeah, and it really is also my favourite planet, I have to say. For astronomers with small to medium telescopes, you really can enjoy following Jupiter. And it's now really high in our northern sky, and will continue for the next 5 or 6 years to be way, way up and very bright through the winter months. So that's Jupiter. We have a couple of other bright planets visible. Saturn, of course, glorious ringed planet, but we're slowly losing it. At the beginning of the month, so tonight and tomorrow night, if you look in the southwest, low down you might see it, but the longer you leave it in the month, the worse it will get, until during February we'll lose Saturn as the sun catches up with it, and we will not see it again until probably August, September time.
Yeah, we're going to be losing another planet this month as well, which is Venus, which is getting lower and lower in the dawn sky.
Yeah, such a magnificent object. This last maybe 18 months we've seen Venus in the evening sky, then it quickly transitioned to the morning sky. You can't miss it. Brilliant, brilliant object. But as you're saying, Steve, it's getting lower, isn't it?
It is.
However, we can also see this month, in mid-month, it will be possible to see the planet Mercury and use Venus as a guide. So around about mid-month, around the 10th, you'll see Venus high in the southeastern sky. And if you look, taking Venus as the middle of a clock, look at a 7 o'clock position, maybe an 8 o'clock position from Venus, very low in the horizon. On the horizon, there you'll see Mercury. Only for a few days, and it's not too bright, but it's very hard to see Mercury because it's so near the sun. So this is a good month. January is a good month to try and see it.
Yeah. And if you're lucky and you see it, you will do something that the famous astronomer Copernicus never managed to do. He never saw Mercury.
Yeah, he lived in Poland, and the skies of Poland in those days were thick with smoke and haze, and he never saw it. Yeah, and that's a shame, isn't it? But we do have two other planets visible, not with the naked eye, unfortunately, but Uranus and Neptune. What about Uranus this month?
Well, Uranus, if you've never seen it before, you've got a very good opportunity on the 19th, because it's going to be easy to locate. You'll see a moon in the sky, and if you look 5 moon diameters below the moon, what looks like the brightest star in that area of the sky is actually the planet Uranus. And if you watch it from week to week, once you've got its position, you'll see that it moves ever so slightly.
Yeah. And Uranus, it's right on the limit of naked eye visibility. So if there's no moon there and you've got a really dark sky and you know exactly where to look, it is possible to see it. And I have to say, dear listeners, that I, this month, or last month in the month of December, managed to see Uranus with the naked eye for the first time.
Yeah. It's something I have never managed in British skies.
Yeah.
I've managed it in African skies, but it's almost overhead, and I was about 8,000 feet up, so there's much less atmosphere in the way, and I was much younger as well, so I think
younger eyes see it.
Younger eyes see ever so much better.
My tired old eyes did manage to see it. It's right now in the constellation of Aries, and I was out at our astronomy observing site at Knowlton, where our new telescope and observatory is situated, and looking at my star chart and gazing up and looking away and looking again, I just caught a glimpse of it, and that's the first time I've ever seen Uranus.
Yeah, it's well done.
Yeah, I was really pleased with it, I have to say.
Yeah.
So we got new moon will be around that time as well on the 11th of January. So we always find that the week either side of that is the best for astronomy, don't we, Steve?
It is, because the moon brightens the sky, so it makes it difficult to see anything other than the brighter stars and planets.
Yeah, and we have a full moon this month around the 25th. So again, a week either side of that, and it just drowns out all the stars and all the lovely objects we have in the sky, and all you can see is the moon.
But if you like the moon, and it's a beautiful object to look at, and if you're just starting out in astronomy, particularly with a telescope, because it's so easy to find, it's something you can get to grips with your telescope on. So don't knock the moon. And the place to look is what's called the terminator. It's the line between light and dark, where you're actually looking where the sun is either rising or setting, depending on what moon phase you're on. And it's glorious. It's things being lit in profile, so they really stand out.
Yeah, so really the best time to observe the moon with binoculars or small telescopes is at half moon or crescent moon, where that terminator, that line between light and dark, is halfway across the moon, and it illuminates the brilliant craters and mare, the seas, so well.
Yeah, and if you're lucky, even with binoculars, you can see just where a mountain top is being lit. So you get these little specks of light which seem to be detached from the rest of the moon. Glorious.
Yeah, they're very nice. So, what about a constellation of the month this month, Steve?
The Great Hunter, Orion. It's one of my favourites.
Really,
it's so distinctive.
Of all the constellations in the sky.
Yeah, it is, I think, the easiest to recognise.
Yeah. And so many of us, I think, started our astronomy days by being able to recognise first the plough. My mum, if she's listening, my mum showed me how to find the plough when I was about 8.
You see, I didn't, because I grew up in the Southern Hemisphere. So.
Yes, it's Southern Cross for you, was it?
Yeah, but even the Southern Cross isn't that distinctive. So, no, but Orion in the Southern Hemisphere is the other way up. So when I came north, everything looked upside down.
That's really true. But we can't miss it.
No.
It sits on the celestial equator.
Yeah.
In other words, it can be seen from every part of the Earth. And it is truly a brilliant constellation. Very easy to see, very easy to recognise. And it's used also as a pointer, as a guidepost to many other stars in the sky.
Well, it's got this famous belt of 3 stars. And if you follow the line of the belt downwards, you get to the brightest star in the night sky, which is Sirius. And you want to watch that on a really clear, crisp night when it's very, very low.
Can you tell me when we'll have one of those, please? We want to... When?
Well, I don't know. I'm an astronomer, not an astrologer forecasting things. But if you look on a really clear, crisp winter night, when it's low in the sky, you will see it appears to flash different colours.
Yes, that's right.
Because the sky's turbulent and it acts like a prism and splits the light, but it's not a constant one, so you get all these different colours. It's lovely.
Flashing rainbow. So that's Sirius, which, as Steve just said, come down from the belt of Orion down. If you go from the belt of Orion up, you come to Aldebaran in the constellation of the Bull, which we talked about last month.
Yeah.
But of course, the main stars in Orion, of course we have the belt, but at the top left, as you look at the constellation, is a very bright orangey, reddy, yellowy star called Betelgeuse. And that is a super brilliant supergiant star. We can actually see its disk from the Earth. It's so big as a star, and it's so close, only 540 light years from us. We can actually see its disk. And it's a super giant. How big is it? Enormous.
Well, if it was where our sun was,
yeah,
we'd be inside it.
Oh.
Mars would be inside it. And Jupiter would only be just outside it.
So it's enormous. But the surface of Betelgeuse is not like the surface of our sun, is it? A really defined surface like the sun has. It's more like
it wobbles.
A pillowy, floppy mass. Yeah. And because it's like that, Betelgeuse actually varies its brightness, Steve.
It does. And a few years ago, it seemed to go very, very dim comparatively to its normal self. And Orion just looked wrong, I think we thought.
dimmed from magnitude 0, which is the brightness measurement, down to magnitude 1.7, meaning really it was quite faint, and it did make a line very strange, didn't it?
It was only a quarter as bright as it usually is. I mean, that was
This was apparently caused by a surface mass ejection of soot, more or less, that obscured or dimmed the surface of Betelgeuse for, what was it, probably 6 months, something like that?
Yeah, and it gradually brightened again. And one of the other things about Betelgeuse, it's sometime in the next probably million years, but it could be tomorrow, or since we're recording this early, it might already have happened. It will go supernova. Now, it's not predictable to the extent of when it will, but when it does, it'll be absolutely fantastic. It'll light up the entire sky, night sky, and it'll be visible in daylight as well.
Yeah. And how do we know that? How do we know that Betelgeuse is going to turn into a supernova?
Well, it's a star called a red giant, and by studying different stars throughout the sky, if you think of it as like walking through an oak forest or something like that, you can see acorns on trees, you can see acorns on the ground sprouting oak leaves and all the rest of it. So you can work out the life cycle of an oak from that. And you do the same with stars. You're only getting a snapshot of different stars at different times, but from that we can actually tell how they work, as it were. Right. And because it's so massive, but I think it's about 8 times the mass of the sun, but I might be wrong on that. When it eventually comes to the end of its life and the nuclear pressure that's pushing outwards comes to an end, it will just collapse in on itself and then go bang in a very spectacular way.
And all that debris, all the material that is in Betelgeuse will be scattered to the 4 winds of the universe.
Oh, yeah.
Including hydrogen, helium, and all the other elements that the star has made and is making as we speak right now. They'll be blasted into the universe, there to be formed again into more stars in the future, and so the cycle continues.
Indeed. In fact, everything you look at and can see on this planet was made inside a star.
Including you, Steve.
Including
I'm looking
me.
At you across the studio.
The only things that aren't is some of the hydrogen was made in the Big Bang, and little bits of helium and a few other things. But even most helium was made inside stars. So we are stardust.
We are indeed.
As they sang at the Woodstock thing.
That's it.
Either that or we're nuclear waste. It's your choice.
So Betelgeuse, why is it orangey red then? Is it temperature, or what causes that?
It's cold. It's the idea, as you heat something up, as it warms up, it goes red hot, then yellow hot, and eventually white hot. And we've got a temperature of just over 3,000 degrees. And that means it's as far as stars are concerned, that's red hot.
Right. So if you could take a piece of coal and heat it up to 3,600 degrees, it would be the same temperature as Betelgeuse.
Yeah, it would actually look a bit whiter. There's a whole sort of contrasty things going on, and we've also got stuff in its atmosphere which is reducing the amount of light coming out of it as well.
So let's talk about the opposite end of Orion. So again, looking at Orion, top left is Betelgeuse, bottom right is a star that is as different from Betelgeuse almost as it's possible to be. And this is the star Rigel.
Now that's a bright bluey white star.
Why bluey white? Because it's extremely hot.
Yep.
And whereas Betelgeuse is 3,600 degrees, Rigel is over 12,000 degrees. So
that is incredible. Yeah. I mean, you can't get anything that hot on Earth without it vaporizing.
Yeah, that's a temperature we can't reach here. Well, maybe
we can, but it's
the middle of an H-bomb.
Yeah,
that's about it. So there you can see Rigel shining low in the southern sky, and it is also a supergiant, super hot, as we said. It's about 860 light years from us, and it's burning through its fuel at a huge rate of knots, whereas Betelgeuse is sort of chomping away at it nicely and will last for much longer still. Rigel is likely to... It's a fairly new star, and it's chewing away its fuel, and suddenly it will also go with a monstrous bang. Not predicted any time in the near future, but Rigel, all blue stars are greedy little monkeys, and they very quickly vaporize and disappear. Yeah. So what else do we know about Rigel? Got a companion star, isn't it?
Yes, I've never seen it.
Oh, really? Well, it takes a moderate telescope, but there's another little. It looks green to me, but it isn't green. There's no such thing as green stars, but there's a little companion star orbiting around Rigel, and you can see that with a 6-inch telescope. You can see it fairly well. The problem, of course, is that Rigel is so bright that the companion star can be, if you haven't got really clean optics, can be lost in the glow there. Yeah. What else about Orion? There must be other things there to note, isn't there?
Oh, yes.
Oh, right. Good.
So one of my favourite bits of Orion is not everybody else's favourite bit of Orion. Mark's going to talk about everybody else's favourite bits of Orion. If you look at the belt of Orion in binoculars, you'll see it's not just 3 stars. It is literally hundreds of stars. It's a cluster. It's called Colander 70. Very catchy name. But I call it the cluster that everybody's seen and nobody knows.
Absolutely.
But it is absolutely glorious. But everybody uses those 3 belts as a guide to something else. If you look just below the 3 belts, you'll see what looks like 3 stars, almost vertical, in a row. And Mark's about to tell us about the middle star of those.
Yes, so below. But back to the Colander 7. Yeah. Definitely take your binoculars and look at the belt of Orion, the 3 bright stars, because there are dozens and dozens of stars you can see there with naked eye. With your binoculars. So hanging down below the belt is the famous sword of Orion, and there in the sword is one of the best sights, to my opinion anyway, in the sky, the so-called Great Orion Nebula. It's easily visible to the naked eye. Better in binoculars, even better in small telescopes, and glorious in a large one. It really is. And
also very, very good in images as well, which bring out the colours in it.
Yeah. In fact, we imaged from our new observatory site in Knowlton, we imaged the Great Orion Nebula a few weeks ago at the beginning of December, and we'll post an image of that on the Forest FM fan page, and also on our Fordingbridge Astronomers website and our Wessex Astronomical Society website.
So what does nebula mean, Mark?
Yeah, nebula is a Greek word. It might be a Latin word.
An ancient word.
Is it? I think it's actually Latin.
I think
nebula, I think so.
Yeah,
Latin
word,
that. Latin O level. And it means cloud. And when you look at the Great Orion Nebula, which was originally catalogued by Charles Messier, our French astronomer friend, as M42. So when you look at M42 with binoculars or a small telescope, it looks like a cloud. To my eye, it looks slightly greeny, bluey. But in the images you see on the website, you'll see lots of orange and lots of red in there.
Well, the red is glowing hydrogen.
Yeah. And the bluey greeny is actually glowing oxygen. And the eye seems to be able to see that easier. Certainly when I look at M42 through a telescope, I never see any red, but the green is very, very obvious.
Our eyes are most sensitive near the green part of the spectrum, so that would make sense.
So what's happening there? We have this massive glowing gas, this cloud of glowing gas, and what's actually happening there? It's a stellar nursery.
It is. So this thing is huge. Its diameter is about 3 times the distance from us to our nearest star.
Yep.
So it's about 12 light years across, which means going at the speed of light, it would take you 12 years to get across it. And it's actually not very dense. If we had it on Earth in a bottle, it would be better than the best vacuum we can get in the best lab. But because there's so much of it, we can see it. And under gravity, this collapses, as gravity makes all things attract each other. And as it collapses, you can press a gas, it gets hot. When it gets up to about 25 million degrees, which it does do, That's enough to start nuclear reactions, triggers them into life, and behold, a star forms.
And we were just, Steve and I were talking about this before we started recording this show. We were trying to figure out how many new stars are born in the M42 nebula. And we reckon it's probably one every century or every couple of centuries.
yes.
So this isn't something you can get your binoculars out and see these stars forming before your very eyes. They are forming, but not quite as frequently as you'd think.
If you want to see them, you could use a Hubble Space Telescope, which, not being facetious, you do actually have it in a sense, because everybody has access to Hubble Space Telescope data.
Yeah, you can see. Yeah,
and you can see these things they call proplyds, these protoplanetary disks which form around stars, so you're seeing natural stars.
Yeah. So there they are. They're forming on a very regular basis in astronomical terms. And over the course of centuries, millennia, and millions of years, M42 will become a star cluster, like the Pleiades, which is not far away. And then we'll have all the nebulosity will have gone, and we'll be left with a collection of a dozen, 100, whatever stars. And then they will slowly move away from each other and join the rest of the galaxy that we're in.
Yeah, it's glorious. So stars have lives just like everything else.
Indeed, they do. So, as I said, we'll put an image of Orion, or a chart of Orion, on the Forest FM fan page. We'll also put some images of M42 for you to have a look at. And don't forget, if you are interested in astronomy, please come and join us. Fordingbridge Astronomers meets on the third Wednesday of every month. So our meeting, I think, will be the 11th. No. The 18th, I think, of January this month. Please come and see us. We meet at the Elm Tree. We're a very friendly bunch of people. And you don't have to know anything about astronomy to come along. You just need to have a general interest.
I think 17th, isn't it?
You could well be right.
Yeah.
Please check.
Please check your calendars. We haven't got one in front of us at the moment.
It's the third Wednesday in the month. However, if you want to go earlier, you can go to the Wessex Astronomical Society. They meet at the Allendale Centre in Wimborne.
And that's on the first Tuesday of the month usually. But do check their website, because sometimes if Tuesday's very early in the month, it has been known to change it to a different date.
Indeed. And, of course, keep listening to Forest FM. We're going to hopefully continue with our starry nights, starry skies all through the year. And we wish you a very, very happy new year and look forward to seeing you next month.
Indeed. So it's goodbye from me, Steve Tonkin.
And goodbye from me, Mark Hardaker. Take care.